All right, so we're looking at 8.4, surface area of a cone. All right, so the first part is a review. I've done the first two for you. It has a circular base at one end and a vertex at the other. That is a cone. Number two, these are the faces of a prism or pyramid that are not bases, so lateral faces. Okay, you're going to try the rest on your own, and then I will help you also with a question here. So you can skip that for now and come back to it. Let's take a look at this. This was on our mid-year assessment as well, so it's a bit of a review for the exam. And I also want to just put this into your long-term memory. So let's take a look at isolating for the variable indicated. In this case, we're isolating for the variable r. So a equal pi r squared. And how do we slowly start getting this r by itself? So the first thing we want to do is divide both the left and the right side by pi. So we have a divided by pi. Let's do that again. A divided by pi is equal to pi r squared divided by pi. And of course, if you divide the right side by pi, it's basically eliminated from there. So we're left with a divided by pi is equal to, let me just fix that up quickly, a divided by pi is equal to r squared. How do we isolate the r? We square root both sides. So if we square root this side, we get a divided by pi. If we square root r squared, we get r. So that is our answer. Okay, let's take a look at the next one. In this case, we're isolating for h, but we have 1/2 base times length times height, or BLH. The volume is equal to 1/2 base times length times height. The first thing I want to do is get rid of the fraction. So let me multiply both sides by 2. And if I do that here, as you know, that eliminates the fraction. Now, for some of you who don't like multiplying and doing all this, just think about it like this, if I may. So if you like this and you're comfortable with it, then copy that down. Other people may prefer to do this, and it works. It's pretty much the same thing. You can think of this like this. Well, 1 times b times l times h is 1 BLH, or just BLH. And the denominator is really 2. So that's another way of looking at the question. And if that's what you're given, then you can simply cross multiply. And the denominator here is really an imaginary 1, right? So what we're going to do is we're going to have 2v equal BLH. Make sense? Now don't forget, the other way was multiplying both sides by 2. If I multiply the left side by 2, I get 2v. If I multiply the right side by 2, I had 1/2 BLH times 2. That eliminated the denominator. So really I had 2v equal BLH. And of course this is the same as that. So it doesn't really matter which method you choose. They both end up doing the same thing. It's the same thing. So pick which one you like and don't worry about it. Now we want to isolate for h. So what's bothering me on the right? The BL. So divide both sides by BL and you get 2v over BL equal h. 2v there. Okay, and that's it. That's your answer. And the third one, I'm going to leave to you. You try that one on your own, and we'll look at it in class together. So for here, I went ahead and made some extra notes some notes in advance for you. The learning goal is that to learn whether or not you can calculate the surface area of a cone. I've input the formula for the surface area of a cone here. That is pi rs plus pi r squared. You know pi r squared is the area of a circle, but then, so that would just give you the area of the circle at the bottom. But then what about this whole entire surface area around the cone? That is called the lateral surface area, and the formula for that is pi rs. The textbook goes through the proof for that and how we got that. But I want you to know that's pi rs, so that's the lateral surface area, plus the circle on the bottom, okay? And I've noted here for you that s is the slant height, okay? The height, or the hypotenuse, that's the slant height right there, okay? So I've gone ahead here. It says calculate the surface area of the cone to the nearest square centimeter. We have everything we need. We have the radius, we have the height of this cone, but we don't know the slant height. And if you look at what I just did with my writing here, I'm looking for the slant height, and as you know, that is really the hypotenuse. So if that's the case, I wrote the steps for you. Step 1, calculate the slant height by using the Pythagorean theorem, which is a squared plus b squared equals c squared. So I went ahead and did that here. A squared plus b squared equals c squared, right? Which is 3 squared plus 8 squared equals c squared. 3 squared is 9, 8 squared is 64. Add them together, you get 73. And then, of course, if you want to get c squared by itself, you square root both sides, and you get the square root of 73 is equal to c. I just left it like that right there because it's an exact answer. Why not? Just leave it like that. All we're going to be using it for is to input it into the formula. So step 2 says sub the information into the surface area of a cone formula. And of course, we put pi r s plus pi r squared. Always start with the formula, please. And then I input all the numbers I knew. I know that 3 is the radius because I got that from the question. So I just subbed 3 into the question there. I know that S is the slant height, and I got that from here. We just calculated it, so S is the slant height right there. And of course, the R squared is, we know that the radius is 3, so we sub it in there as 3 squared. Okay, so all our information has been put into the formula for the surface area of a cone. And then I put here, use your GDC, because I don't need to be showing 15 steps here. Once you've shown the first step here and the second step, once you've shown, sorry, that step here, you've written the formula, and you've shown the second step where you've input all the information, why not use your graphic display calculator? So I'm going to try this on the script calculator that I have on the iPad. Pi times 3 times square root 73 plus pi 3. Okay, let's try that here. So I have pi times 3 times the square root of 73 plus pi times the radius, which is that squared. See if that will do that all for me. Perfect. And I get 108.7996, which is about 108.8. So I'll put a little dot above my equal sign and say approximately 108.8. And because we're calculating the surface area and we're given units that are centimeters, we'll say 108.8 squared centimeters. And that's it. That looks more like a line than it does a dot, doesn't it? Okay, there we go. 108.8 squared centimeters. This last question, a funnel is in the shape of a cone and has a radius of 5 centimeters and a height of 20 centimeters. If it is full and drains at a rate of 25 milliliters per second, how long will it take to empty? So what you're really looking at here is, this is full, so you need to find the volume, right? How much can this hold? And then it drains at 25 mils per second. Well, if you find the volume is going to be cubic centimeters, right? Which you should know 1 cubic centimeter is equal to 1 milliliter. So once you find the volume, you really also found how many milliliters it holds. And then if it drains at 25 milliliters per second, how long will it take ballpark to empty? I'm going to leave that to you. You're going to figure this one out on your own, and we'll check that in class as well. And that's your last question. Okay? So fill in some blanks. You're going to answer one question here in terms of isolating a variable. I've given you some information there, and you're going to find one answer at the bottom there. Okay? See you in class.